Okay, so let's take a look at 4A number 3. Some of the homework problems were A, B, and D. So let's go through those. They're square root equations. All of them are square roots. And so the strategy that we discussed for those was isolate the square root if there's only one, and then as long as the x term's inside of it, and then you can square both sides. And so we even wrote that down here for this example. I think it said something like the strategy isolate the square root term if x is inside, and then square both sides. Okay, so let's do that up here. The square root term is already isolated, so I'm just going to rewrite this way. And now square roots and squares are inverse operations. They cancel each other out. So when you square a square root, you're just left with the inside. And that 4 squared is 16. And then if I subtract 25 from both sides, I'll get x equals -9. And then to check it, well, we plug it back into the original. So over here, I'm going to do square root. So second square root, second root. What is it? X plus 25, and x is -9 plus 25. And we get 4, which is what we're supposed to get. So that works. So it's not an extraneous solution. Okay. Part B, part B, the root is already isolated again. So we're already ready to square both sides. I'll use a different color here. So we'll write x plus 1 and square it equals the other side squared. And again, square roots and squares are inverse operations, so they undo each other. So this side turns into just 7x plus 15. On the other side, it's not x squared plus 1 squared. You got to FOIL it out. You got to distribute everything out. So this would turn into x squared plus x plus another x plus 1 equals 7x plus 15. If I simplify this a little bit, I'll put this all the way up here. This will be x squared plus 2x plus 1 equals 7x plus 15. We can subtract 7x from both sides and subtract 15 from both sides. So if we bring all that junk over here, we'll get x squared and then minus 7x. We'll turn that into -5x. Subtracting 15, we'll turn this into minus 14. And now we've got it to equal 0. So at this point, we could use quadratic formula, or we could split the middle term. It's got to multiply to AC, which would be -14. And it's got to add to B, which is -5. So two values that do that would be -7 and +2. And so this can turn into x squared minus 7x plus 2x minus 14 is 0. And then if I factor by grouping, I'm going to get x minus 7 plus 2 x minus 7 equals 0. So that's going to turn into x plus 2 times x minus 7 equals 0. So x plus 2 is 0, or x minus 7 is 0. So then x is -2, or x is 7. And then we would plug those back in to check. So let's check x equals -2. So let me move this out of the way here. Whoop. Oh, shucks. Hold on. Okay, so check. X equals -2. If we plug it in, we've got, we're plugging it into this here. So it's -2 plus 1 is -1. And then we want to see if the other side's also -1. But if you think about it, it's already a root. And there's no negative in front, so it's got to be a positive number. So this isn't going to work. But if we plug it in anyway, plug in -2, we end up with the square root of 1 which is what? Positive 1. So this one is extraneous, right? So x equals -2 is extraneous. If we check x equals 7, then we plug it in. 7 plus 1 is 8. And on the other side, we've got root 7 times 7 plus 15. So that's root 7 times 7 is 49 plus 15. Well, actually, we could just plug all this into the calculator. So it's the root of 7 times 7 plus 15. Whoops. Shucks. Hold on. Plus 15. And we got 8, which is the same. So that one checks out. So x equals 7 is our answer here. And the other one didn't work. Okay, for part D, what we're going to do is, we discussed this in class, there are 2 square roots in it. And so the strategy now is to get 1 root on each side of the equals. So if we add root x minus 1 to both sides, then we're going to get root 5x plus 4 equals root x minus 1. And now it's ready to square both sides, because if we square both sides, the squares and the square roots undo each other. And I'm left with 5x plus 4 equals x minus 1. Now it's a pretty straightforward problem. If I bring the x over here, that becomes 4x. If I subtract 4 from both sides, I get equals -5. So then x equals -5 over 4. And then we got to check it. So in the original, so square root of 5. Actually, let me do this, because -5/4. I don't want to type that in over and over. So I'm going to type in -5 divided by 4. And then down here near the bottom is that STO arrow button, store. And then right here is a shortcut for x. So x. So if I hit that, now it's stored as x. And now I'm going to type in square root of 5x plus 4. And then move it out, minus the square root of x minus 1. Whoops, don't need a parentheses there. And if I hit enter on that, let's see what we get. Non-real answer. Interesting. -5/4. Yeah, that gets messed up right over here. If you plug in -5/4 into there, 5 times, whoops, let me clear that out. 5 times -5 over 4 plus 4 is a negative number underneath that root, which is not going to work. Oh, and in fact, you get a negative number under this root too, so that's not going to work either. So this is an extraneous solution. So that one doesn't count, which really means there's no solution for this problem. Which probably means, let's check this out on Desmos real quick. If we go to Desmos and I graph the left side of the equation, let me type this in here. Whoop, sorry about that. So it's essentially y equals the square root of 5x plus 4 minus the square root of x minus 1. And the question is, when does that equal 0? So when does it have the y value of 0? So really we're looking for when the blue line and the red line hit each other. And if you look at them, it seems pretty clear to me that they probably aren't going to hit each other. And if I zoom way out and then kind of scroll way over here, you can see that one curve is always going up and the blue line just stays put. So they never actually hit each other, which means they're never actually equal to each other. Okay, so all right, so no solution.